I was going to tell you how I fix stuff. So today we have this Bohn Contex 30, and these Bohn Contex machines are actually pretty cool. They were intended to be like, super low end, super cheap, small, easy to make, and they still have a surprising amount of functionality. So this machine has a couple of issues, but it mostly works. So we'll plug it in and take a look. So for adding, it's just like your regular, what you'd expect for a 10 key machine. You enter a number, hit the plus button, and it transfers it down there to the register. This one of our issues, the 6 key, has a problem. For subtraction, basically the same thing. Like if you want to subtract, say, that's funny. He won't work in that position. So 6 doesn't work. Oh, nothing wants to work in that position. 4 works. Z will subtract. Clearing works. To clear the keyboard is that. Multiplication is pretty cool. So we can do, say, 25, push the multiply key down, and now this changes to an on-the-fly multiplier. So we've got 25, so we can do 5, and then 2. And there we go, 625. So multiplication works. And then to pop that back up, you just return that home and it releases it. For division, you hit this all the way over key, and see that is kind of sticky, it doesn't always slide all the way over. Add that in. And now it's starting to work. And then, so the way the division works on here is it doesn't have a traditional counter, like a full counter register, it just has a 1-digit counter here. So it'll go through and extract the 1 digit, 3, and then you push this once, and then extract the next digit, 1, 4, 1, 5, 9, 2, 9, 2, and I'm not sure what the next digit is. I got a 3, I don't know if that's right or not. But anyway, that's the end of that. Clear that out, clear that out. So like I said, mostly it seems to work. And a couple of sticky issues in the slider here, a couple of iffy keys on the keyboard. And once we get in here, we'll have to check. The way that this machine works is actually a reciprocating machine, which is kind of unusual for 10 key but no printer. The way that they did the pegboard on these machines is instead of using springs to hold the pegs in their actuated position, they just used some polyurethane foam, kind of like this stuff. And what can happen is over time that degrades and it loses its, basically its poofiness. It doesn't put enough pressure on the pegs in the pegboard to keep them in their appropriate position. So we may or may not have to rebuild that if the pegs are going to have a problem. Because what can happen is, it'll work fine for multiplication or for addition and subtraction, but once you start doing multiplication and division, where the machine's running a lot with the setting in the pegboard, the vibration can sometimes move some of the pegs in and out, and then you start to get inaccurate results. So as we saw here, that doesn't seem to be happening that we can tell, but that doesn't necessarily mean that it won't happen in the future, or that it's going to be 100% correct all the time. So anyway, to take this apart, you have to take this little thing off of here, which let's right off like that. I don't think you have to take this out. I think this is just a stop for division or something, maybe. Not sure. I'll have to look into that. It does have the directions on the bottom. You can kind of see there, including how to, it has how to use the slider thing. Actually, no, I guess it doesn't. I don't really see that here. What I'm talking about is this thing. This is used to determine where your decimal point goes for division. I know in the Context 20 they have a bit of an explanation how to use that, but I don't really notice it on here, so I have to check the Contex 20 out to remind myself how that's used. I don't see that here. Anyway, so I have to take out one screw right here and another one on the other side right there. So we'll do that, and then the cover should come right off. Alright, so we are in here. You can see the register in the front there. And right here is the pegboard. I'm not sure if you'll be able to see down in there. Let's try entering. You can see, you kind of see it moving across. Oh, you can see the pegs right there. If I clear this. I should try entering 8. Can you see the pegs? Yeah, I think you can kind of see the pegs on the very bottom there are now protruding, so that's for 8. And then these pieces in here are the, they rock backwards, or like these ends rock down until they hit a peg, and then the front end, which you can see that right there, the front end has teeth on it that drive those little gears that then run forward up to the register. And for subtraction, basically the whole register just shifts out and over, so that these gears here move to the other side of those tooth sections, so that it basically just turns the gear backwards. So pretty simple operation for that. I haven't worked on one of these before, so I'm not exactly sure how the multiplication mechanism interfaces with the keyboard. If this is similar to the Contex 20, the way that they take the motion of these down to the pegboard, basically they have a big long spring under each key that's then funneled through kind of like a plastic guide. So when you push the key down, it pushes that spring down, and then the spring kind of like extends along the guide until it hits the peg and extends. So that's, I'm assuming that's where the issue is going to be with number 6. They all have issues. 4 worked once. So if I hit 5, 4 still works, but it didn't work for a minute there. So let's see, what works in this position? 1 works, 2 works, 3 works, 4 works. I think 5 doesn't work. 6 piano doesn't work, 7 doesn't work, 8 works, 9 works. So I think what I'm going to do is look into taking this whole keyboard assembly out. I know on the Contex 20, I think it wasn't super complicated. Look at the process on here. In the back, here they have this little induction motor. I noticed they have fans on either end of it, which were not present in the Contex 20. And I actually have a Contex 20 that I think has a motor failure, so that may be why they added those. I'm not sure if this has the same setup. In the Contex 20 they have the motor, and they have a centrifugal clutch on the gear here, so that the gear will only engage with the motor once the motor is up to a certain speed. I don't really see that here though. Looks like the fan is where that normally would be. So anyway, let's look into taking this out. Might be kind of complicated because of the multiplication mechanism, but we'll see. So the issue is not what I thought it was. I thought it was that, the spring in under the 6 key was messed up somehow, but it's actually not. It was the pegs in the pegboard were stuck. So initially I was going to take this back piece off here, because you can see how the top of the keyboard kind of slots in here, and you have to take this off and then possibly undo some other things, and the keyboard can come out kind of, but it won't come out with this here because of that tab in there. And it's held in by a screw here and a screw here, which are Allen screws, and as usual I never have the right Allen wrench, so I ended up just advancing the pegboard out and then getting down in here with a pick and a screwdriver, and I was able to free up all those keys. So now the 6 works all the way across. Put a little bit of oil on this. I think there's another shaft in the bottom I should oil yet, but div tab seems to work okay now. No longer getting stuck there. Put some oil on each of the rocker bearings in there, and a clean up in between the keys here. And I think we can just do a little demo. I think it's going to be about it for this one, just a little short video. You can see over here the motor capacitors. I'm not sure why they have so many. I think this is the main motor run capacitor. Not sure what the other two are for. Maybe, suppression from the switch or something. This is the switch here. In the Contex 20, this is completely exposed. Maybe I'll get out of Contex 20 and we can do a little comparison. But that's going to be about it for the repair on this one. Like I said, the keyboard seems to work okay. I did feel how stiff the pegs are in the pegboard, and they are okay, I guess. They don't have as much drag as I would like them to have, but we're going to have to let it run for now until I can go get a proper Allen wrench to take these off. And maybe when we do that, we'll do some work on the Contex 22. But just a little short repair on this one for now. So here's compared to the Contex 20. They changed the color scheme here a little bit. And also the Contex 20 has a double counter register, because this one has manual multiplication where you just hold the button in until you've entered the number you want to multiply by. So they have the counter for additions as well, so you know when to at least move on to the next digit. Whereas because this one has the on-the-fly multiplier, you don't have to care about that, so it just has the counter for subtraction. Other than that, you can see that these are pretty similar here. I was talking about here where the switch is just exposed like that, and there's a little peg on the gear that connects and disconnects it, versus this one has the arm going up into a little enclosure there. And let me flip these around. Oh, something else too. Notice how this gear here just has a shaft that ends with a C-clip there, while this one has the shaft that goes in and it has two little teeth on the end of it that mesh with a gear down in there. Not sure where you can see that. It's probably for the on-the-fly multiplier, like a cycle counter or something, I'm assuming. We can these around here. And you can see the difference there in the motor, how this one has the double fan, while this one has no fan, and this is that centrifugal clutch I was talking about. So see, I can spin the motor shaft while the gear is stationary. This one I don't think has that option. No, the gear is firmly attached to the motor shaft. So, so it looks like this one has one less capacitor too, I think. So it has an extra capacitor in there for some reason. So anyway, like I mentioned, I have another Contex 20 that I think the motor is failing in. It'll work okay for a little bit, and then after a while the motor won't be able to get enough speed to engage this clutch, and the motor will just spin and the machine won't do anything. And the only thing I can think of is it's a failing in the windings somewhere, because I've taken the whole assembly out, taken the motor all apart. There's no issue with the bearings or anything. Everything spins nice and free. But that still happens after a while. The motor just doesn't get enough speed to engage the clutch and spin the gear. And I have tried changing the motor on capacitor and everything too, and that didn't make any difference. So there's some extra solder there. That's fun. But anyway, this is a one I got for parts, so someday I'll probably do a video either fixing this one or swapping the motor if it's good from this one to my other one. But anyway, this is a little comparison. Pretty similar actually, there's only a few minor differences. Look at the side, this one has a piece of dirt there. Get that out. Useless Allen keys. See, the cord on this one is pretty sad too. Like someone tried to splice an end on, I don't know why. It's this bad to begin with. Anyway, versus the cord on this one. Of course, I don't know if that's original or not, but yeah, from this angle they look pretty much the same. I don't really see any differences from this side. So yeah, I do. This one There's an extra thing there. This one doesn't have it. And this is part of the case. This is those go on the inside of the case there like that, and that's what the screws go into. So one of them's broken off this case. And this case is pretty sad too for the 20. You can see it's cracked there, and it's cracked there too. And it's missing the thing that just broke off actually. So anyway, like I was talking about before, the directions on the bottom here. Here, to find decimal and division. And we're setting on the compiling code. There are more whole numbers in the dividend than in the divisor. Set the box on the sliding decimal scale over the black digit that equals the difference between them. Example, 641 divided by 25, set box over 1. So that would be, this box here set over 1. At the completion of the problem, the red pointer arrow will indicate on the upper scale the number of places in the quotient to be pointed off from the right. There are more whole numbers in the divisor than in the dividend. Set the box over the red figure. It equals the difference between them. Example, 1.43 divided by 7.2. Set the box equal to the red 1. So I guess what they're saying is, and we can try that too. So for example, like if we were doing our regular 355 divided by 113, we would set this to 0 because there's no difference between them. And then as the pegboard moves across and the red pointer moves, it tells you how many decimal points to point off from the right. So I guess that, like, if we just do the 1 division, like if you just do the first digit, then it would be 0, and so on. So we'll try that then, once we put it all back together, which I think we can do now. Alright, so everything's all back together now, so we can do that is correct. We already know the subtraction works, but say we have like 97 minus 15. That seems to work. And you can see how the register moved over to do the subtraction. So let's do 625. You can multiply by 5. And that is correct. 55. So now, since our divisor and dividend have equal digits, we'll put it on 0, and also 3, and right now we would have 0 behind the decimal point. I think that's how it works anyway. Yeah, I think it was digits pointing off from the right. So right now we would have 0 behind the decimal point, just a 3 in front of the decimal point. Now if we shift over, so now pointing off from the right, we would have 1 digit behind the decimal point, so 3.1. That seems to make sense. And then 4, so 3.14. Now we have 2 digits. 1, 5, 9, 2, 9, and then the last looks like it runs off the end there, so I guess you're probably not supposed to go that far. 2, and I'm not sure that's right. Didn't even read correct from that overflow, so maybe the last digit there doesn't always do that, but anyway, I'm going to call that a success. That's definitely enough, factors for anybody's division anyway. I can't imagine you need to go more than that, and most machines don't. But anyway, I'm going to call that satisfactory. Everything seems to work just fine. Clean it up a little bit. So that's about it for this one. I hope you enjoyed this quick little look at this. I think it's a pretty cool machine. I mean, you know, how small this is, and like I said, it was designed for, you know, designed to be cheap, designed to a price, but how much functionality they were able to fit in there. Yeah, I think it's pretty cool. Definitely a size differential there. So, hope you enjoyed this video, and thank you for watching.